Thanks, Sivia, and hello, everybody. We appreciate you joining us today to check out Open Policy Agent, or OPA, and why we think it's a game changer for any team that's responsible for the security and compliance of their cloud. In the past year, we've seen cloud-based exploits graduate from simple attacks to far more sophisticated ones that take advantage of multiple misconfiguration vulnerabilities and often go completely undetected by traditional security tools. You're probably here because you recognize the nature and scale of the problem, and that continuing to rely on manual processes for security and compliance puts our data at risk, wastes resources, and just slows everybody down. The answer is automation using policy as code, but not all policy as code tools are the same, and none offer the power and flexibility that OPA does. Here to talk about OPA and how it can transform cloud security and compliance at your organization is Josh Stella, co-founder and CTO here at Fugue. I'll be back after to facilitate your questions, so get those in early and often. With that, I'll hand it off to you, Josh.
Thank you, Drew. Thank you, Sivia. I think this is going to be fun and interesting. So as Drew explained to us, we're going to do a number of things in this session. First, we're going to go through an overview of misconfiguration risk in the cloud era. The reason we're going to do this is our main focus at Fugue using OPA is around cloud configuration and misconfiguration. And by the way, like many of you, we're working from home these days. So if you hear some street noise or my big dog, please forgive me. We're going to go over that misconfiguration risk in the cloud era. We're going to look at why policy as code is so critical for security and compliance, really mandatory to do it properly. We're going to spend a fair amount of time introducing you to Open Policy Agent for policy as code, including the growing OPA ecosystem of tools. The folks who wrote it call it OPA, by the way. So then we're going to do a little bit of technical deep dive into the OPA toolbox. We're not going to get into a tutorial on writing Rego rules. Rego is OPA's language, but we are going to get into a relatively deep dive on how you can use this. There are some pretty good tutorials out there for learning the language itself. It's pretty easy to get started. And then we're going to talk about getting started with policy as code using OPA. And of course, all of your hopefully fine and challenging questions we will get to in the end. All right, a little bit about cloud misconfiguration. It is a major security risk. Neil McDonald at Gartner, nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. Definitely agree with that, both in my time at AWS and since Drew and I founded Fugue. We see this all day, every day. Last year at Fugue, we did a major survey of over 300 organizations operating at scale on the cloud, and 93% of them said they were concerned for a major security breach due to misconfiguration. That really should be 100%, but 93 is a pretty good starting place. So folks understand that this is a major attack vector. So in terms of what is getting attacked, what people are concerned with in terms of their cloud infrastructure configurations that are vulnerable, again, from the same survey, 2/3 said they're concerned with identity and access management misconfiguration. That's a really, again, should be 100%, but the fact that it is first shows a couple of things. One, people are recognizing that IAM is this new, very cloud native attack vector and one you have to be very concerned with. That is true. And two, that it's hard to figure out if it's right. And this is the kind of place where policy as code using OPA can be amazingly powerful as compared to any of the other approaches out there. Second in line, security group rules, things like open ingress ports that are insecure, also a major concern. We see both of these used in a majority of breaches in the cloud. And another thing that can be handled with OPA policies. And then object storage access policies. This, we're talking about S3 and blob storage, things like that. These are the ones that make the news. It's usually some combination, actually, of IAM security group and object storage access policies. But another place where OPA can be used, and this is going to sound a little inception here, a little meta, but you can use OPA policies to check the access policies of your object storage to make sure that they are safe and secure. And then finally, encryption in transit, encryption at rest, of course, too. Again, policy as code can help you here. So these cloud misconfigurations that expose us to risk are often overlooked, and there are reasons for this. It's because many dangerous cloud misconfigurations are not recognized as misconfigurations by the security teams, because most security teams have been primarily focused on data center era approaches to security, things like securing your network perimeter, watching network traffic, endpoint security, looking for unusual behaviors. They're not clued in yet to things like slight misconfigurations to IAM roles and policies, and et cetera. So the security teams don't identify, in many cases, cloud misconfigurations that expose you to risk. And one of the reasons for that is the compliance frameworks like CIS benchmark, NIST 800-53. And by the way, we at Feud deal with these security policies and compliance frameworks all day long. That's what our product will help you with. What we're seeing is the vectors the bad guys are using in terms of attacking your infrastructure via misconfiguration. Those compliance frameworks are just way behind on keeping up with the innovation in the hacker community. And because of those two things, these misconfigurations are exceedingly common in enterprise cloud environments. And because those cloud environments are constantly changing, right? In the old days of the data center, it took months to build a network. I can do it in a minute, a big complex network, and I can tear it down in a few minutes. So that the surface itself, the infrastructure configuration itself, is constantly changing in the cloud. And therefore, these misconfigurations are like looking for needles that are continuously appearing in a haystack that is constantly growing and shrinking. A little bit of a forced analogy there, but not too bad, I don't think. So let's talk about how hackers are going after your stuff. Kind of the Hollywood version of how hackers act, and this is true. It does happen at times. They'll identify an organization. You know, the North Koreans got really mad that Sony Pictures made a movie that was not exactly, to their liking about North Korea. And so they went after Sony because Sony mocked them a little bit, to be honest. And they looked for vulnerabilities. Often, so that's one, identify your target organization. Two, search for vulnerabilities to exploit. Often these kinds of attacks are affected not as much through misconfiguration, but through things like spear phishing and so on, and then, you know, shifting to misconfiguration. But those are a very small percentage of the successful attacks and breaches in the world these days. What we're seeing much more of, and even some of the really high profile big name breaches, is the bad guy wasn't targeting that organization. They were using automation to identify any vulnerabilities on the internet and then going down the list of targets that had misconfigured resources to decide who to attack. So in other words, bad guy sets a bot in motion. A friend of mine who works in the kind of red teaming and hacking analysis space told me that if you put a IP endpoint or DNS record that's public facing on the internet, once it's live, the bad guys are probably going to find it and identify its misconfigurations and vulnerabilities within 7 minutes. So there is no security through obscurity anymore. because the bad guys have fully automated, and they have large, sophisticated networks that are identifying every mistake you make and doing that very quickly. Then once they get a list back, maybe a hacker's life, I wake up in the morning, make some coffee, scan through my report on who I can hack today that my bots went and found. And then I not only know who they are, but I know what misconfiguration they have, because that's what the bot was looking for. And so it's not surprising that they are often extremely successful. So the bad actors are using automation to find and exploit cloud misconfigurations. They're doing it very quickly. And just an example of what this might look like, and this is a recreation of a very high-profile attack that happened last year. Bad guy first found a firewall misconfiguration, a security group that had overly liberal access. Once again, something OPA could protect, as we'll show you. Then two, the bad guy found an EC2 instance that had a CVE on it. What that means is it was probably unpatched, it was probably orphaned infrastructure, and therefore vulnerable. And all of your unknown and orphaned infrastructure is very lucrative attack surface for bad guys. Step 3 in that breach was getting better IAM access to try to get to S3. Again, something OPA could catch. And 4, bucket discovery and duplication out of S3. Again, something you could use OPA to catch. And this is exactly what we do at Fugue. By the way, this is not going to be a big product pitch and demo. The focus today is really on OPA, but we are a massive user of OPA. And so in our context, this really has to do with this cloud misconfiguration problem. We will speak to some other use cases too. All right, why do you need policy as code? Well, because the cloud attack surface is complex and ever expanding. In the data center, it was physical infrastructure that you manage yourself. So often this would be servers, switches, networks. There were dedicated teams that would be assembling these things, that would be talking to vendors to do the best product selection. It usually took months to make significant changes to that infrastructure. There were usually always change going on, but it had a long kind of process that got to that change, usually involving, again, a procurement process, contracts being written, stuff being shipped, devices being racked and stacked, change control boards deciding on how it would be configured, and therefore pretty static as compared to cloud. However, also manually deployed, configured, and maintained. And that, I believe, is one of the key weaknesses of the data center from a security perspective versus the cloud. So in the cloud, you have software-defined infrastructure. API calls, I mentioned earlier. I can build the equivalent of a very complex corporate network in literally minutes, if not a minute, in the cloud, just by running a simple program that generates all of that. And because of that, the cloud is extremely dynamic. There isn't a procurement process for a VPC network. It's just an API call. Which means these things are deployed, configured, and maintained via APIs, application programming interfaces. That can be done kind of manually through like a web console or through the command line, or you can use things like Terraform or CloudFormation to do infrastructure as code, or Ansible, or Chef, or writing your own Python scripts, or Pulumi. There's a bunch of choices there. Clearly, automation is good from an efficiency perspective and so on, but infrastructure as code absolutely cannot do what policy as code does and is an inadequate replacement for it. They are really separate concerns. Infrastructure as code is all about automating what you're building, increasing velocity, increasing repeatability. Policy as code is about making sure what you're building is correct, no matter how it's built. So the world we live in now, developers build and modify their own infrastructure environments, unlike in the old days, right? So this new complexity requires policy as code for security at scale, in particular because the bad guys are automated. You have 7 minutes, right? So how are you going to do that while your developers are constantly building new infrastructure? So let's do another little comparison here. In the data center, infrastructure teams would build out an infrastructure. There's usually a network team. There was usually a operations team that owns servers, and they build out an infrastructure environment and they put VMware on it, or maybe today they're putting Kubernetes on it, and or both, and 5 other things, and then they offer it up to the application teams to take pieces of it. So the infrastructure in the data center old days was the relatively slow-moving part, and you packed applications into it. It had partial and inconsistent API coverage, right? The data center does not have, well, if you've got a data center that has complete and consistent API coverage, man, do I want to interview you, because I've never seen it. It's usually, you've got some switches from one vendor and there's some API there. You've got, virtual machines or containers that are using other products, and there's a separate API there, and everyone is kind of a snowflake. And usually there are big chunks of it that really don't have API coverage, and that leads to validation and audit generally performed manually, because you can't just write a program, you can't write a policy that can look across the whole data center. And that may have been okay because it was so slow moving, but actually, having lived through a lot of scenarios, both at AWS and when I worked in national security environments, those audits are painfully slow and usually wrong. In fact, I say usually, but in my experience, they're always wrong. It's a question of how wrong. So in the cloud, the developers, as we talked about, are creating and modifying their own infrastructure via actually completing consistent APIs. You really can't do anything in cloud except via its APIs, which is awesome from a productivity perspective, and from a discoverability perspective, and from a security perspective, because if we're using policy as code, we can now do validations and audits in a completely automated way with policy as code. We can go faster than 7 minutes. We can do it in seconds. Now, most people are still doing it manually with like scan and report security tools, or grepping through logs, or doing manual reporting. That is, in my view, very much the wrong approach. When the better option is to use policy as code to make sure you're correct at all times. So that policy as code empowers engineers to own the security of their cloud-based systems. They already do, by the way, but policy as code enables them to do it correctly, to do it safely and correctly. So policy as code provides developers and engineers in general with security feedback. Those of you who aren't developers, I've been a developer. Actually, I've been more of a software architect for a number of years now, but I still like to write code, and I've done a lot of it in my life. You might picture developers as people who can imagine a whole system in their head and then sit down and start typing it out and it runs. That is not how, that unicorn developer might exist somewhere. I've never met them. What really the process for writing code is trying things and having your tools tell you where you're wrong, and doing that many, 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 many times a day. So in traditional programming languages, what you're expressing when you write code are logical functions. There are two fundamental things in computing, in software. There are instructions and data. So what we're doing is we're writing some kind of functions. I don't mean that with a mathematical context. I mean it kind of generally executable code that operates on data. And programming languages have compilers or interpreters that give feedback to developers on whether the instructions they're writing are any good. And most of the time they're not out of the gate, and those tools tell us how to fix it. So an example, I might make a goofy mistake, like trying to multiply a floating point number, a number with a decimal in it, with a string of characters, just because I got a variable name wrong. If my compiler or interpreter is any good, it's going to tell me, hey, that's pretty dumb. You probably don't want to try to multiply a string by a floating point value because you're going to get an unexpected result. So that's what programming languages are really good at. And those developers out there, I'm sorry for the really simple description, but I think it's a decent one. They're really designed to tell you if your program is going to work and if it's going to work as you intended it. Policy as code has a slightly different purpose. Policy as code is an assertion. In OPA, it's a declaration of what the security posture shall be. And so your security posture can therefore, in OPA using Rego, be expressed as code. So policy as code evaluation, if done early in the software development lifecycle, which is what we have implemented and advocate at Fugue, actually we do it all the way through the software development lifecycle at Fugue, what it will do is tell developers the same way your compiler or interpreter tells you whether you're doing your logic right. OPA, using these kinds of approaches, and we have a free project out there that I'll show you shortly that will help you with this, will tell you if what you're doing in cloud infrastructure as code or just generally in cloud infrastructure is correct from a security posture. So where the compiler might tell you, don't multiply a string, we, OPA, using things like regular open source project or Fugue, our product, will tell you, don't leave your VPC's default security group open to egress to the world because that's equally dumb. So developers are going to want to get things correct from a security perspective, and with policy as code, we can appeal to developers using the same tooling, the same way that they have worked with languages for many decades now, just fitting into their world, empowering them to get it right. Okay, a little on Open Policy Agent. It is a relatively new open standard for policy as code. Fugue adopted OPA a year and a half ago into our products. And back then, it was a kind of small project, actually. And it's been amazing to see it take off. We picked it out because we looked at the language. We've done a lot of work at Fugue. We have a lot of patents around writing policy as code languages and compilers and so on. But we wanted to use something open, not something just that we were using, specific to Fugue. And when we saw OPA, we looked at it and said, wow, this is actually really very good. So let's go ahead and adopt it. And since then, we've been thrilled to see it get sponsored by the Cloud Native Computing Foundation, the folks who maintain Kubernetes. It is based on writing declarative policies using a language called Rego, which is the language for OPA. It's kind of a declarative query and predicate language. It's really easy to learn for simple use cases, and it allows you to go to very sophisticated use cases. It can validate any JSON data. We say output here. Very often Rego and OPA are used to validate things like HTTP transactions in service-based architectures. We at Fugue use it in a kind of broader way or a different way around cloud infrastructure as deployed and also infrastructure as code. But the basic idea is if you have a JSON data structure, you can use Rego and OPA to validate or invalidate that within a particular context. And so it can be adopted and has been adopted for a wide variety of cloud use cases. We at Fugue do it for cloud infrastructure, for AWS, Azure, Google, looking at whether your infrastructure is going to be safe and secure. I think that when I went out and had the opportunity to speak at KubeCon last year at the OPA day, which was like standing room only, actually barely standing room, just very, very packed room, tons of energy around it. The vast majority of use cases we saw from folks like Pinterest and Netflix and so on were really around determining in service architectures based on Kubernetes whether one service with a certain set of credentials or a certain set of session credentials can or should be able to make a call to a particular call to another service. Very, very different use case. You can also do it for things like API governance. It's just really nicely designed to be a general purpose answer to this problem. And I think that, and you don't have to write it in XML or JSON. Thank you. Humans should never write XML files or JSON files. It's crazy. So Rego is actually a pretty little language. And I'll show some of it to you shortly. There is a robust and growing tooling ecosystem. We point out a couple of the things we've contributed here to open source at Fugue. Regula for validating Terraform, and Frego, which is just kind of better developer tooling for Rego. But there's a lot of other stuff going on out there too, and I'm going to walk you through quite a bit of it. So let's talk about proprietary policy as code, quote unquote, air quote policy as code versus open policy agent. So what we mean by proprietary is that you often will see in products, we see it all the time in cloud security products, where there is a kind of baked in semi-language for expressing policies. You see it in the firewall world, plenty, but in the cloud security world, it's an endemic, I think, problem. It tends to be very single use case, not just a single use case from a business perspective, but mapped to a single vendor's product, and therefore therefore carries lock-in and vendor risk to that proprietary offering. So a lot of times you'll see this as like a semi-realized version of SQL or a Python library that's baked into a product where it's mapped just narrowly to that product and the data structures that product supports, and is kind of baked into that proprietary system. Very often that means you have limited or no version control. By the way, things like GitHub and VS Code now understand Rego, right? They're not going to understand these proprietary kind of semi-languages. So version control gets harder. Very often they're quite inflexible for sophisticated requirements because they tend to have not been thought through from an architectural perspective and a language design perspective to work against as many use cases as possible, but instead to solve some particular customer requirement to sell product. And those are very, very different things. They rarely have much in the way of an ecosystem or community. I mean, if you're talking about, Cisco stuff, there's a big community out there, but a lot of these vendors are smaller than Cisco. And even in Cisco's case, some of their products, don't have the biggest community. Whereas in the open source world, you can really build that community. The rules are typically completely not portable. And what that means is when you assign engineers to do this stuff, it's spinach, not dessert, right? They're going to gain limited marketable skills. And therefore, you're also going to have a hard time finding people who already know those skills. Now, if you contrast that with Open Policy Agent, which, by the way, is the first reasonable open standard for doing this with its own runtime and so on. There are other things that have come in the past in the kind of bad old days of the WS star standards, a few of which were okay, but mostly bad old days. But they didn't really have runtimes. The runtimes were all, vendor by vendor. OPA is a runtime as well, and it's a really cool runtime. And so you don't need to go learn some schema and then go buy some big giant product. You can just download it off GitHub and run it. It works against multiple use cases. Like any really good piece of kind of systems software as opposed to application software, I can't think of the end of the use cases personally. Maybe you can, I can't. It is just generally applicable to anything expressed in JSON, and that's awesome. That means there's no lock-in or vendor risk. Well, are you locked into OPA and Rego? Well, if you've written code in it, I mean, if you write code in anything, you've invested in it. But the beauty here is it's not attached to any particular vendor or product. You can use version control the same way you do for anything else in GitHub or GitLab or whatever. It's extremely flexible for sophisticated requirements. We've done some pretty fancy stuff with OPA and Rego ourselves, which is part of why we built some tooling for it to do things like give better error messages. It's really powerful. It's gaining a ton of traction and has a robust ecosystem and community. The rules are often portable. Now, this is going to depend on the data structures, obviously. If you're writing rules against data structures, those data structures are going to determine the efficacy of the rules. But with a little bit of forethought, you can get quite a bit of portability out of OPA, and there's just no way you'll get that out of the proprietary systems. And finally, when folks like, Pinterest, Netflix, Spira, Fugue, many others are using OPA, that means that engineers have a reason to learn it because it's a market. It is becoming more and more a marketable skill, and that means you will be able to find people who have learned it. By the way, it's also pretty fun to use and powerful and not crummy. So engineers so far that I've worked with actually really enjoy using it. Okay, a common myth I hear. Infrastructure as code is a prerequisite for policy as code. Nonsense, that's backwards. People say we're not ready for policy as code because we haven't yet adopted infrastructure as code. This is so full of fallacies that it's not even wrong. I'm going to start at one end of it. So one, your infrastructure as code, if you believe that everything you're doing in infrastructure is expressed as infrastructure as code, I will make a bet with you here and now that you are wrong. Somewhere in your organization, people are doing things outside of that Terraform or CloudFormation pipeline. And there are reasons for that. And they are good reasons, and that will not change ever. So you cannot just apply policy as code to infrastructure as code because it will leak. It will leak every time somebody goes into the console and makes a change that wasn't in infrastructure as code. It will leak every time you use a tool that makes any modification to the running infrastructure post-deployment that is not expressed in the infrastructure as code, including, by the way, some of the security tools out there. Right? If you're running Lambdas to modify infrastructure post-deployment, then your policy as code, if it's only applied at the infrastructure as code level, has no idea what's happening in the infrastructure. So you need to start with policy as code. You can run it against the running infrastructure. You don't need infrastructure as code. If you use both together, you can shift the whole policy interpretation, or much of it, to the left in the SDLC. But you definitely don't need to be using infrastructure as code for policy as code. And if you believe that running policy as code against your infrastructure as code is good enough, you will get hacked because you're wrong. Okay, the reality, well, I just spoke to this. I got ahead of myself. You need policy as code because the disparate methods used to create and modify cloud-based systems impact your security posture. Right? It may be manual, consoles and GUIs, maintenance windows, system is down, somebody goes in to make tweaks. Are they going to modify Terraform code in your repo and ask for a pull request at 2 o'clock in the morning and get an approval to that, and then go through the CI/CD pipeline to make one small change so that they can get a system back up and running? Maybe your answer is yes. I think you're wrong if your answer is yes. You should not do that because your competitors are not going to do that, and they're going to fix their systems faster. Obviously, CI/CD pipelines will modify things, usually in several ways. Some of it infrastructure as code, but some of it, multiple services configuring and automating via APIs. When you look at something even like Elastic Beanstalk, Does your infrastructure as code even come close, if you're calling Elastic Beanstalk, to knowing what the final configuration is? No, it does not. So automating cloud security with policy as code across the SDLC. This is the holy grail, right? We have one set of policies that we can use from design through deployment all the way through to enforcement in the runtime. This is exactly what we're doing at Fugue. We think it's the right approach. You can start at any one of these places. But if you're doing infrastructure as code and policy as code, you can do it in all three. So during design phase, actually, I'm going to work backwards because I would recommend that you work backwards too. I would start with looking at the deployed infrastructure using policy as code, not the infrastructure as code. I think that comes later in terms of how to understand how to use policy as code. But the important thing here is we need the same policies, in this case, OPA policies, to be applied on all these steps. So working backwards, enforcement, you can go look using policy as code at all of your configurations that are deployed. You can continuously look at them, in fact, using those policies and find out whether the infrastructure actually meets those policies. That's a good starting place. You already have deployed infrastructure. There's no big fancy tooling project needed. You can just point something like the completely free version of Fugue that's chock full of OPA rules that will tell you all kinds of things about your security posture. Just point at your infrastructure, and it'll use those policies to tell you what your security posture is. Then working backwards, you can integrate those same policies if you're using OPA, not if you're using a proprietary language that only works ex post facto, or a proprietary or open source tool that only works during design phase. Neither of those will help you through the life cycle. But if you're using OPA through the whole life cycle, the same policies you use against production for enforcing things, you can use to check at deployment time. So you can use them to prevent deploying misconfigurations by integrating them into a CI/CD pipeline. And then finally, but earliest, right? In the design phase, if you're doing infrastructure as code, a certain amount of infractions of policy can be caught by examining your infrastructure as code. I estimate it to be around half of the real world problems you might introduce from misconfiguration. It's definitely not 75% or north of that, but half is pretty good, right? If you can catch all the errors you're making in Terraform prior to doing the deployment, if you can catch half of them prior to actually even doing a Terraform apply, that's a good thing. So this can work across the entire SDLC, and in fact should, and in my opinion, in our opinion, Fugue must. Okay, I'm gonna stop with the slides. If you're used to our webinars, you're used to me writing code. I'm not gonna do that today. I'll show you some code, but I'm really just kind of give you a sort of tour of the ecosystem and a little bit about, oh boy, Zoom is getting in my way again. Darn it. Let me get this out of the way. I forgot to open my code editor. We'll come back to that, but we'll start here. So step number one, go to openpolicyagent.org. This has no affiliation with Fugue. This is its own project. It's one we use and contribute to heavily. It's a really good place to start getting to know OPA. And I'm jealous. They have this little Viking helmet with horn logo. It's pretty cool. All right, so let's talk about what this is. Styra are the folks who maintain it. They've done a really wonderful job. So here we're talking about, they're just explaining it's about declarative policy. So what's declarative policy? In this case, we're talking in a Kubernetes environment. There's a package. It's a real language. Kubernetes.admission, deny if the request kind is pods where it is not coming from Huli. Okay, that's in a nutshell what this is saying. So they've got a nice little REPL that you can use online. So here's our code on the left. I mentioned before, What we're doing is actually, let's go back here and show you their little diagram. Yeah, so you're talking about taking policy and data and comparing those and evaluating the data through the policy. So here is the input, that's the data. Here is the rego, that's the policy, and we can do an evaluation. And here you can see it's saying, well, we only want images coming from Huli, and one of these came from Nginx, and one of them came from MySQL, and those are denies, right? So handy tooling there. Fugue's built a bunch of tooling too that we'll show you, but handy tooling there. It can apply across many use cases. So there's Kubernetes, how about Envoy? So here's a way to, declare what can hit different HTTP endpoints. So this is allowing for gets on the /pets part of the REST endpoint. And you can also do stuff, in applications themselves to look at, the actual source code, the actual behavior of the application. So it's very broadly applicable. A little bit about its architecture. You can run it as a daemon, and you can run it as a library. I've seen we at Fugue use it as a library. It scales really nicely. We run probably north of 500 million evaluations a day using OPA. We actually built a project to make it much, much faster, which you can get off of GitHub if you run into issues around execution time. But the native project itself, the original project's super fast. Lots of people are using it. You can do it as a daemon. You can stand it up as a service. You're going to incur, of course, additional latency if you do that, or you can just package it in as a library into whatever you're running. There's good tool support out there. VS Code has cool support for it. There's that Rego playground. There's a CLI and a REPL. Fugue has actually produced another REPL to give better error messages and breakpoints and stuff like that. And maybe, super importantly, Cloud Native Computing Foundation, that means you're going to see a lot of adoption. So just quickly to, let's see, who's adopted it. This is the GitHub repo, Open Policy Agent /OPA. Who's using it? Ball.com, Chef, Cloudflare, Fugue, Intuit, Medallia, Netflix, Plex, SAP, Tremolo, very good security, Cisco, Pinterest, SolarWinds, Yelp. So a lot of folks are picking it up, right? A lot of folks are picking it up. At Fugue, we have produced a couple of tools for you that are open source using OPA in addition to our core product. One is called Regula. You can get that at our GitHub repo at Fugue/Regula. And what Regula does is it evaluates Terraform for policy prior to deployment. So if you're using Terraform with AWS, Azure, or Google Cloud, we have a bunch of stuff out there to help you with validating whether the things you're doing are secure and safe or not. We have created a GitHub action for this, so you actually don't even have to run anything if you want to try it out. I'm going to jump over to my code editor here to show you a little bit of Regula, which also, by the way, will show you a little bit about how cool and easy to use Rego is. So this is just I've just gotten the repo out of GitHub. This is an example of one of the rules we built for AWS. And so we can do packages, we can do abstractions, which is really handy because it can make your source code where you're actually writing the rules extremely readable and extremely succinct while being highly expressive. So here we're saying this rule applies to anything using AWS's CloudTrail. So when Regula is examining the output of a Terraform plan file, which is how it works, it looks for any CloudTrail resources. It then does a mapping to things like CIS benchmark, which is where we've started. So CIS2 TAC2. is where this applies. Default allow equal false means basically assume everything is bad unless our policy says it's good. And then here is the one case that we're pointing out in this rule for what is good. The allowed block is saying if the input enable log validation equals true, then allow that. So that's a very simple policy that's included in Regula. We're adding more all the time. You can see these can get more sophisticated. So super easy to learn, but you can get into some pretty sophisticated stuff. So this is dealing with IAM user attached policies. Still not that hard, right? Less than 50 lines of code. Things like KMS key rotation, one line of code, one line of functioning code. Here we've got two for security group ingress from anywhere to RDP. We've also built rules for Azure and for GCP. We're just really getting started. We put this out a little over a month ago, and it's getting a ton of traction. I'm running low on time, so let's just show a couple more things in our libraries. So I mentioned earlier that Rego allows you to do these super, simple things very easily, but it allows you to do very sophisticated things very elegantly. And this is an example of that. So here we've built a bunch of utility code for working with things like the plan file output from Terraform, which is a bit messy. So a bunch of utility functions that can be called. And this just shows that you can do real software engineering, real programming using Rego. And even so, it's less than 200 lines of code. But you're not typically going to see the ability to do creative and innovative and useful work in these proprietary kinds of languages. So one other open source project that we've released at Fugue to help you with OPA, we write a whole lot of OPA at Fugue, and we wanted world-class error messages, breakpoints, debugging. So we created a tool, a project that's again on GitHub called Frego, which is the Fugue Rego toolkit. And what it will do is give you a much better experience in terms of error messages, debugging, setting breakpoints, etc., for working with Rego. So hopefully you'll enjoy using that. You can do break, help, input, open, et cetera, et cetera. It's all up here in this GitHub repo at Fugue Frego. We've heard, we ourselves find it much easier to write, especially complex Rego, using this than without it. A secret about Frego is because we run so many evaluations a day against very large data sets at Fugue, hundreds of millions, we wanted a full lazy evaluation mode for actually evaluating OPA. And so Frego is actually an evaluation environment itself, and it's the one we run in our product. Just briefly, that was all about looking at infrastructure as code combined with policy as code. I went on at length in the slides about why you don't need that. You don't need infrastructure as code. So here's why. Here's an example of this. So this is the Fugue developer product, which is free forever. It's a SaaS. You can go to fugue.co and get it. And none of this, okay, what we're doing here is we are examining an existent cloud environment via its APIs and collecting together JSON artifacts to describe all of the configuration of these items. So if I look here at this load balancer, you can see we've just captured a ton of data, and this is all captured in JSON, and that means we can run OPA against it. We don't need infrastructure as code. We can use those same OPA rules to actually examine everything, the tags, everything in that deployed environment. This is a diagram that we automatically generate, the internet here on the left going into VPCs. There's a gateway, a load balancer, collection of EC2 instances, etc. And then everything turned red here is because it failed an OPA rule, and Fugue has just hundreds and hundreds of these things baked into it. So in this case, that OPA policy was looking to see that the VPC default security group should restrict all traffic. By the way, if you don't know this, you get this wonderful gift from AWS, whether you want it or not, that will not show up in your infrastructure as code template. It's a side effect of creating a VPC, that you get a default security group that allows egress to world on all ports, which from a security perspective is nuts. You should not have that on. So we're catching that, and that's using OPA. And of course, also in Fugue, you're able to embed your own OPA rules. And I'm showing it here in a GUI, but you can do all this via API with Fugue as well. And of course, Fugue Developer is free forever. You can just point it at your accounts and plug in your OPA rules, or use the hundreds we've baked in. Here's an example of a custom one, and see how you're doing from a security posture perspective. So you don't need to have infrastructure as code run policy as code. In fact, if you point Fugue at your environment, you can use policy as code in like 10 minutes against all these standards, including your own custom rules, to see how you're doing on your infrastructure, and then use those same rules over time back into further left on the software development life cycle. Okay. Let's go back to the slideshow, and I think I only have the end slide. Yep. So getting started, go to openpolicyagent.org. If you want to see what your security posture is using OPA rules right now, you can go to fugue.co/go. Again, we have a developer version that will analyze up to 1,500 cloud resources and tell you using OPA whether they're safe or not, based on just lots and lots of rules that we've already baked in. If you're using Terraform, you can go to github.com/fugue/regula and get Regula, which will check your Terraform plan files. You can do it again with a GitHub action. If you're writing Rego, strongly recommend you check out Frego. Again, all open source. And then also our good friends at NLT have created something called the Automated Infrastructure Compliance Framework, which leverages pieces of Regula and their own way they wanted to integrate with CI/CD, and it's super cool. So you can check that out too. All right, Drew, did we get any questions?
We do have some questions. First up is, how well does OPA scale?
Drew, are you with me?
Yes, can you hear me? Hello? Can you hear me?
Drew, I can hear you, yes.
Okay, the question is has well does OPA scale?
Oh, that's a great question. So OPA scales extremely well, has been our experience. When you think about an organization like Pinterest, who are using it, and I won't try to speak to their use case in too much detail, but are generally speaking using it for their service architecture on a transaction basis, you can imagine that's a whole lot of transactions. In Fugue's case, we're actually using it hundreds of millions of times a day against cloud infrastructure environments. Now, we did build our own evaluation implementation that's baked into Frego for that, but it scales really, really nicely.
Okay, great, thanks. The next question is, how can policy as code support a distributed high-tempo development where devs are deploying infrastructure with their software?
That's a good question. So So that's why I pointed out that you don't need to start with infrastructure as code. If you assume your developers, I'm assuming what you mean by their own software, they're choosing how they are doing deployments in that cloud environment. Maybe one team is using Ansible, one's using Terraform, one's clicking around at the console. By pointing Fugue Developer Edition at that, you can get this kind of information back, instantaneously to the environment so that they can see exactly where they're getting things right and getting things wrong. I'm showing this in a visual form. It also comes back via API in a data form or a report. So the beauty of this approach, and this is why it's so important to use the same policies all the way through the software development lifecycle, from what you're using to look at instantiated infrastructure back to your infrastructure as code. Because if you're using different tools with different expressions and different interpretations, you're going to get a lot of conflict over the course of the software development lifecycle. So it can be done. It's easy to do, especially just pointing at Fugue Developer and the big collection of OPA rules there. You can load your own into it, and no matter what your devs are using or how fast they're going, you can know all the time what your security and policy posture is. And do other stuff too, like enforcement and so on. But
Yep. Yeah, the next question's interesting. I think you touched on it. It's why should policy as code have its own language? And I think you were getting at this because you have developers and different teams that are using different languages, and you don't want to have a bunch of different policy as code frameworks for each of those, right?
yeah, so when you're developing software, when you're doing engineering, you're always thinking about, what compromises do I need to make? And to do that, you're looking at the available options. So when you're thinking about policy as code, historically, there are really three approaches. One is to do something like write a unit test library, or even like a function library in a particular language, Python, Java, C#, C, whatever, that deals with programs written in that language, right? So there's a real problem with this. Back in the 90s and early aughts, it kind of looked like we were headed to there really only being two main programming languages or environments in Java and .NET, and maybe everything would just standardize around those. But that is, as we now know, very much not what happened. Instead, we have a polyglot world where Golang has taken off, Rust has taken off. Thank God Lisp is back in the form of Clojure. Lisp being, in my opinion, one of the most beautiful languages ever. And the reason we can do this polyglot programming is because we're using service architectures, and each of these services written in whatever language makes sense for you talks JSON to the other services, typically over HTTP or asynchronous messaging protocols. So what that means is having policy as code that is concerned only with one language is quite deficient and doesn't make sense in the kind of polyglot world. Well, why not do a kind of general purpose policy as code written in a general purpose programming language? Well, the reason is the problem space is both much more discrete, right? General purpose languages, Turing complete languages, etc., are intended to write functional programs. Policy as code is intended to mostly tell you no or yes, or score things. So it's a more discrete problem space. Therefore, you can write a simpler, more elegant language without carrying along with it the burden of learning a general purpose language. So far I've compared two of the historic approaches. One, write something in a specific language, either tailored for that language or an extension of that language. Two, write Rego, which is this nice, elegant, sort of declarative query language. Obviously, I think the second is by far superior to the first, and also to the third. The third being write some giant definition of what the requirements for a policy language are, and leave it up to vendors to implement different solutions to it, which in my experience, those approaches are kind of always bad. So that was a bit philosophical, but the short summary is Rego is easier to learn than a general purpose language and applies to anything, whether it's running on a mainframe in COBOL from a bank, written in Rust, written in Clojure, running in Lambda, it doesn't matter.
Awesome. Okay, well, we have gone a little over time, so we will reach out to those who posed questions and we were not able to get those. We'll reach out to you individually to answer those, and want to thank everybody for taking some time with us today. This was fun, and look for some information on the next series of webinars we'll be doing. Thanks, everybody.